All right, guys, Mr. Antonucci here, and in this video, we're going to talk about the chain rule. We'll go through a bunch of examples, and stay tuned at the end. I'm going to go over some AP style questions as well. So when we talk about the chain rule, this is primarily talking about differentiating composite functions. That's where you have one function inside of another function. So if we look at this function, the inside is the 3x cubed minus 6x plus 14. We could call that u. We could rewrite this function as f of u equals u to the 7th. So let's look at what the actual chain rule is. The chain rule is the derivative of that composite function. So if I have the derivative with respect to x of f of g of x, that is going to be equal to the derivative of f evaluated at g times the derivative of g of x. You can think of this as outside and inside functions. The outside is f, the inside or inner is g. So you take the derivative of the outside with the inside still there, then times the derivative of the inside. We're going to look at a lot of examples here to get the hang of this. First off, we're going to look at the original function that we looked at here, capital F of x. If we want to take the derivative of this, want to use correct notation, capital F prime of x equals. Now, the inside function is going to stay there. So 3x cubed minus 6x plus 14. The 7 comes down, and the new exponent would be 6. Because if you think of this as u to the 7th, then the derivative of u to the 7th would be 7u to the 6th. Then you multiply by the derivative of the inside, which is 9x squared minus 6. But be careful here, since that's a binomial, you're going to need parentheses. Typically, this is all the further you're going to have to go. You won't really need to simplify that anymore. It's just going to be some tedious algebra. Here's another one. The important thing with the chain rule is identifying what the inner and outer functions are. So the 3x minus pi over 4 is the inside of the cosine function. So this is really playing the role of u. So g prime, again using correct notation, the derivative of the outside, which is cosine, the derivative of cosine is negative sine of 3x minus pi over 4 times the derivative of the inside, which is just 3. We can clean this up a little bit. That 3 can multiply in front and write negative 3 sine of 3x minus pi over 4. You can't distribute the 3 into the sign, so just be careful about that. Now, in this case with a radical, you would want to rewrite it as x squared plus 1 to the 1/2 power. And then we can use the chain rule. Here, the u, or the inside, is x squared plus 1. So when we write y prime, the outer function is the power function. So the power rule says bring the half down, multiply x squared plus 1. The new exponent would be negative 1/2, and the inside is x squared plus 1, so its derivative is 2x. Now this one we can simplify a little bit. Couple things here. The negative exponent would drop down to the denominator, and you'd have x squared plus 1 to the positive 1/2. That would be next to the 2 from the 1/2 right here. And then the numerator would still be the 2x. Then the 2's would cancel, and the 1/2 exponent you could rewrite as square root. So this would be x over square root x squared plus 1. A quick way to do derivatives with the square root is if you have the square root of a function, we'll call it g of x, it turns out that the pattern is the derivative of the inside over twice the original square root, like this. And you can see that in this example here, but the 2's canceled. All right, here we have y equals tangent e to the x. So the inner function is e to the x and the outer is tangent. So when we get the derivative, I'm going to use dy dx here for this notation. That's going to be secant squared e to the x, so the derivative of the outside with the inside still there, times the derivative of the inside. And we could clean this up by writing it as e to the x times secant squared e to the x. Again, you can't distribute that e to the x inside to the secant function. In this case, The inside function, we can notate it with u, is x squared minus 4. Now this brings up an important point because we could rewrite e to the x squared minus 4 as y equals e to the u, where u is a separate function. So the derivative of that gives us a general procedure for finding the derivative of e to a function. What I mean by that is the derivative of e is itself times the derivative of whatever was in the exponent. We'll call it u prime. So a general pattern is u prime e to the u. So in this case, if you had y equals e to the x squared minus 4, the u, x squared minus 4, would make the u prime 2x times e to the u, e to the x squared minus 4. Here, the u, is 4e to the x. And again, we can think of this as y equals sine of u. And then this can give us a nice rule for the derivative of sine of any function. If I took the derivative of this, it would be cosine of u times the derivative of whatever that u function is, which would be u prime. I could clean this up and write it as u prime cosine of u. Now with that, you can apply this to all 6 trig functions, and it's going to be u prime times the derivative of whatever the outside trig function is. Here, I'm going to use dy dx. The outside is sine, so its derivative is cosine of 4e to the x times the derivative of the inside. So the 4e to the x, the derivative is just 4e to the x. Cleaning this up a little bit, this 4e to the x can come out front, and you would write it as 4e to the x cosine of 4e to the x. Similarly with natural logs, identifying the inside is important. So it's 3x squared minus 7x. And if we rewrite this in terms of u, this would be y equals natural log of u. And if u is a function, we would apply the chain rule. So y prime is going to be 1 over u times u prime. We could simplify that to u prime over u. And I bring this up because this gives us a good pattern for finding the derivative of natural log with the chain rule. The derivative is going to be u prime, so in this case 6x minus 7, over u, 3x squared minus 7x. See how that's u prime over u. So here we want to find the equation of the tangent line to the graph at the given point. Now remember, a tangent line problem, you need the slope and the point. They already gave you the point. The slope is equal to the derivative evaluated at that point. So if we take the derivative, here again, the u is the exponent on the e. It's 4x. So u prime is going to be 5 times 4 e to the 4x, which is just 20 e to the 4x. Now y prime, evaluated at x equals 0, because that's the x value of that point, is going to be 20 e to the 4 times 0, which e to the 0 is going to end up being 1. So 20 times 1 is just 20, and that's going to be the slope. So the equation of the tangent line is y equals the y value plus the slope times x minus 0. So this simplifies to 20x plus 5. And we'll show this to you in Desmos real quick. All right, so we've graphed our function, the point, and the tangent line. Another thing that you could do, let f of x equal 5e to the 4x. Then the point 0, 5 can still be there. Then you could also write the equation of the tangent line in function notation. So there'd be y equals f of 0, so the function evaluated at the point, plus f prime of 0 times x minus, in this case, 0. And notice that line's right up. But this is just y1 plus the slope times x minus x1. So you can do this with different functions. Here's another one using the radical. So I'm going to do the trick that I showed you a minute ago, where f prime is equal to the derivative of the inside over twice the original square root. And then that's just going to simplify to 1 over 2x plus 1 inside the radical. And then f prime of 4 is going to give us the slope. So 1 over root 2 times 4 plus 1, which is going to end up being 9. So that makes the slope 1/3. And our tangent line equation is y equals 3 plus 1/3 times x minus 4. For what value of x does the graph of f of x have a slope of 2? This is essentially solving the equation f prime of x equals 2 because it has the slope of 2. So we would have to take the derivative, set this equal to 2, and then solve for x. F prime, the e to the x squared is e to the u, so u prime, e to the u, minus, now the x cosine x is a product rule. So derivative of the first, I'm going to put this whole product rule in brackets because I'm subtracting the product. So derivative of the first times the second plus the first times the derivative of the second. Now I left that minus because I know that the derivative of cosine is negative sine, and that's going to change the plus to a minus. If we distribute the subtraction, it's going to be minus cosine x plus x sine x. And then you would set that equal to 2 and solve for x. But see what I mean about this being algebraically impossible? So we'll hop on over to Desmos to figure this out. Okay, so here's the graph of the derivative, and we want to find out when this graph is equal to 2. Type in the equation y equals 2, and then the intersection point, could copy and paste that for here, and that's going to give us the x value when the slope is 2 of that original function. You want to report your answer to at least 3 decimal places because that's what's required on the AP exam. Now, before I move on, I want to show you an alternate way to solve this problem. Here is the original function, and what we're asked to do is find when it has a slope of 2. Well, nice thing about Desmos is you can have it automatically graph the derivative, so f prime. I can turn off the original and then still type in the equation y equals 2, and notice we'll get the same answer. But in this instance, I did not actually have to find the derivative function. Desmos can do that for me. You're not always going to be able to do that because not all problems is Desmos permitted. So here's another kind of problem that can come up is where they don't actually give you a function or a graph. They just give you a table of selected values and they tell you some information. So h is equal to f of g of x. So we know it's a composite function. If we want to find h prime of 1, first thing we want to do is take the derivative of h using notation. So I don't know what the functions are, but I know how the chain rule works with notation. It's the derivative of the outside, so we'd write that as f prime, with the inside still there, times the derivative of the inside, g prime. Then h prime of 1 is going to be f prime of g of 1 times g prime of 1. Then you just use the table of values to fill this in. So g of 1 is 2. This means that 2 is being plugged into f prime times g prime of 1 is negative 3. So times negative 3. Then finally, I can get what f prime of 2 is. F prime of 2 is negative 4. So that's going to be negative 4 times negative 3, which is 12. This kind of problem comes up on AP exams a lot. Speaking of AP exams, let's look at a sample free response question. So we have the graph of a function f. It's 3 line segments. Suppose g is a function whose derivative is f. So this is very important that we understand what we're talking about here because we have multiple different functions. Also notice in the question below the graph, there's another function called h. So the graph of f is what's given. It says that g's derivative is f. So I'm going to write that right on the graph, that the graph of f equals g prime. It says suppose y equals x plus 7 is the equation for the line tangent to the graph of g at x equals negative 3. Let h be the function defined by h of x equals g of x squared. Find h prime of -3. So h prime, we have to use the chain rule. So the exponent comes down, the inside's still there. The new exponent would just be 1, so we don't have to write that, times the derivative of the inside, which is g prime. Now we want to find h prime of -3. So plugging -3 in, that would be 2 times g of -3 times g prime of -3. So that's going to equal 2 g of -3 right here. We don't know what the function g is, but we do know that the equation for the tangent line to the graph of g at x equals -3 is y equals x plus 7. Why that is significant is because at this particular point, we're trying to figure out what the value of g is, and a tangent line at that point is going to share the same value. The tangent line, if we plug in -3, has a y value of 4. Since the tangent line and the curve of g are going to share that point, they would have the same y value. And then g prime of -3 is equal to the value of the graph at -3, which is 1. So if we multiply that all out, we get 8. All right, guys, that's it for this topic on the chain rule. Hope that was helpful to you. Make sure you subscribe. Take care.